Hi everyone, Mr. Kwan here. Today we're going to talk about applications of quadratic functions. Our first example says that Mr. Kwan is selling boba and finds that his profits are modeled by the function p of x equals negative 0.1 x squared plus 300x minus 1200. Find the number of units Mr. Kwan needs to sell in order to maintain the maximum profits, in order to attain the maximum profits and find the maximum profit. So, in a previous video, we established that in order to figure out the vertex, we need the x value, x equals negative b over 2a. Now, one thing to note is that our a value here is negative 0.1. Because it's negative, what that means is that if we were to graph this, it's going to be a frowny face, or it will open downwards. And so what that means is that somewhere at the vertex, it's going to have our maximum value. So let's figure out what negative b over 2a is. So our b value is 300. And then our a value is negative 0.1. And so the negatives will divide out, and so we'll be left with 300 over 2 times 1 over 0.1. 300 divided by 2 is 150, and I'm going to rewrite 0.1 as a fraction, so that's 1 over 10. And then that's equal to 150 times 10, which is 1500. What that number represents is the number of units that I need to sell in order to attain my maximum profits. So on the graph here, what that would look like is this number would be 1500, and then the profits would be that value there. So right now, we don't know what that is, but we are going to figure that out. So what we want to do is we want to plug in 1500 into our profit function. So I'm going to have p of 1500 is equal to negative 0.1 times 1500 squared plus 300 times 1500 minus 1200. And just to save a little bit of time, I went ahead and I plugged that into my calculator, and I got 223,800. Okay, so I'm going to come back up here on my graph and just write in 223,800. And let's just write a couple of sentences so that we really solidify what the answers that we got mean. So we would say, Mr. Kwan would need to sell 1,500 cups of boba in order to gain a max profit of $223,800. That's a lot of money, so I gotta get working on selling that boba. Okay, let's move on to example 2. So it says the owner of a skating rink rents the rink for parties at $600 if 50 or fewer skaters attend, so that the cost per person is $12 if 50 attend. For each 5 skaters above 50, she reduces the price per skater by 50 cents. Construct a table that gives the revenue generated if 50, 60, and 70 skaters attend. So I'm going to make a table. This table is going to look a little bit different just because normally we just have 2 variables, the input and the output, but I'm going to make 3 columns for this table. The first column I'm going to have represent the price, and the second column will be the number of skaters. And then the last column will be the total revenue. Okay, so in the problem, it's established that if there are 50 skaters, then the price per skater would be $12. And in order to figure out the revenue, we would just multiply those numbers together. So $12 per skater times 50 skaters gives us a total revenue of $600. So if we increased the number of skaters to 60, notice that it says for each 5 skaters above 50, she reduces the price by 50 cents. So if we brought in 60 skaters, then we would reduce the price by 50 cents twice, since that's a difference of 10, so it's 5 twice. So we'd subtract 50 cents twice, which would give us $11. And if I multiplied those, our total revenue would be $660. Now, one more time, if I add 10 more skaters, that would reduce the price per skater to $10 per skater. And then if I multiplied those, we would get $700 in total revenue. So B asks us to construct the equation that describes the revenue for parties with X more than 50 skaters. So usually for revenue, our revenue function, we use R of X to represent revenue. And the first part of this represents the amount that we're discounting. So we would start off with $12 and we're subtracting off 50 cents for each additional 5 skaters. And then we're multiplying that by the number of skaters, which would be 50 plus 5 times X. And it's important to note here that X is the number of each additional 5 skaters. Because remember, the owner of the skating rink is only offering a 50-cent discount for each additional 5 skaters. So X is the number of each additional 5 skaters. Okay? So part C says find the number of skaters that will maximize the revenue. So I'm just going to copy the revenue function from up above. We have 12 minus 0.5x times the quantity 50 plus 5x. Now, if you FOIL that out, I've already FOILed it ahead of time, so I'm just going to write out what it is in standard form. So if you FOIL it out, you should get negative 2.5x squared plus 35x plus 600. And we want to maximize the revenue function here. Again, notice that our a value is negative, so if we were to graph our parabola, it would look something like that, like a frowny face. And we know that the x-coordinate of our vertex here is negative b over 2a. So let's just figure out what that is. Okay, so our b value is 35. And our a value is negative 2.5. So if we simplify that, that would be negative 35 divided by negative 5, which equals 7. So our x value is equal to 7. Now remember, the way that we defined x up here is x is the number of each additional 5 skaters. So if we get a value of x equals 7, what that means is that in order to maximize profits, the owner should invite, so 7 represents the number of each additional 5 skaters. So 7 times 5 is 35, but that's additional to the original 50. So it would be 50 plus 35, which is 85. So in order to maximize profits, the owner should invite 85 skaters. And again, the way that I got 85 is 7 times 5 is 35, and then 35 plus the original 50 skaters is 85. So that's where I got that number from. Okay.